Stop talking. Why it's not on? What happened to this? Switch on that. Switch on that. It's not in a blue color. Yes, pass. Shall we start? Yes. Even if you say no, I will start the session and I will complete the second module, right? Okay, the next topic is TCP flow control. So next topic is TCP flow control. So here, the TCP it is going to provide a flow control service for the application to eliminate possibilities like for the sender overwriting feed. Okay, here the flow control is a speed matching where it is going to serve the speed matching rate with the server side and also the client side. Okay, here the TCP it is going to provide the flow control having the sender maintenance variable called the service receiver window, and the receiver window you can check here. It is given with a formula like receiver buffer is equals to minus of last byte received minus of last byte read. So here we are having a 4 constraints. First is last byte read, second is last byte receive, and also the buffer constraints. So here the TCP flow control is nothing but the speed matching between the rate of which the data has been flown from the client to the service, like the server end. Okay, here the TCP it provides the flow control having the sender it is going to maintain a variable called the receive window. So in the receive window, the client it is going to check the space form. So here it is going to check the space whether there is a space to send the data or not. Okay, to store the data or not, whether there is a space or not. So by checking that space, it is going to send the data using the IP addresses from the client. Okay, then by using the TCP data connection, so it will check the buffering constraints within the window side, within the receiver window. Okay, here we are having the formula called receiver window is equals to receive buffer equals minus last received byte received and also last byte read. Okay, here we can see the application in this diagram where we are having the socket where it is going to act as a switch, right? Where whatever the data it is going to come to that particular position, it is going to switch on to that. the socket will check the data and it will render to the particular destination path, right, by using the IP code. So here you are having the receiver advertise free buffer spacing by including the receiver window value. So as we have seen previously by in the reliable data transmission, for each data what we are passing, there will be having a sequence number and also there will be some byte address and also timing will be allotted. So here the receiver window will be having some value within the particular header fragments. What we have seen in the yesterday segment header in the TCP segment header, right? It is going to set the flag status value, whether it is going to be in a value 1 or 0. So it is going to set the receiver buffer size and also within the window it is going to check that whether the data which have been passed from the client, in what state it has been, whether it has acknowledged or it's still processing, or what, in which condition the data has been in the receiver window. So it guarantees the receiver buffer will not overflow. Buffer in the sense over will multiple times the data should not process. Once it has sent from the client, the sender should automatically get that particular acknowledgement for that data which has been sent from the client. No need to have the too many processing, right? We need to give the time slot for the particular data what we are sending from the client to the server. Okay, so there should not be a buffering for more than 20 seconds or more than 50 seconds. There should not occur buffers in the particular data transaction which will be done using the TCP connection. Okay, so you can see the buffer receiver buffer will be rewritten in the window size to the application process. So free buffer space is checking up the space and also updating in the next level. Okay, so this tells about your flow control. And next is connection management. So when we see this connection management, we are having a 3 phases. One is connection establishment phase, data transmission phase, and also connection termination phase. So in this connection establishment phase, we are having the 3 steps. So here we are having the 3 steps. First step is in the connection management. In the connection establishment phase, as I written there, the TCP connection management, 3 phases. First is connection establishment phase. What you need? Is it necessary now? It's already updated in your Teams. No need to note down. As you are a student, you know, right? You should get the pen in your bag. Huh? This is the valid reason. Okay, in the first phase, it is a connection establishment phase. We are having a 3 steps. First, step 1, the client side in the TCP. First, it is going to send a special TCP segment to the server side. In the first step, the TCP, it is going to send a special TCP segment to the server side. So this special segment, it contains no application layer data, but one of the flag bit. So here the flag, it is going to set the segments, whether it should be a 0 or 1. So if it is going to set 1, so it is going to give the sync acknowledgement. It is going to sync the connection with the receiver from the client to the server end. So when it is the flag is set as a 1, it gives the sync acknowledgement. In the step 2, once the IP datagram, it is going to contain the TCP sync segment, it is going to arrive at the server host. Once in the first step, it is going to sync. It is going to get the flag. It is going to set with the 1, condition 1. So it is going to get the sync statement. Once it is got the sync statement, in the step 2, what it is going to do, it is going to arrive at the server host. It is going to arrive at the server host and it is going to extract the connection, TCP segment connection with the initial sync segment. In the step 3, it is going to guarantee that we have the handshaking property. In the step 3, from the client to the server, there is a connection. It is going to send it is going to set a 0, stating that we have connected with a client to server end. We have transferred the data, and the data transmission, the first data transmission is completely done. So it's going to set the flag to 0 value and terminate for the first condition. This is how your connection establishment phase it is going to be done. So in this diagram, you can check the two-way handshake property. Already we have learned in the many topics, right? The handshaking property, two-way in the sense only the client and also server will be acting as a two constraints. The server will be having the TCP connection, reliable data transmission connection, and it is going to establish a connection with the server end. So requesting the path with the server and the acknowledgement is getting from the server. This is how the two-way of connection will be done. Sometimes the failure may occur. So in the two-way handshaking property, sometimes the failure may occur. When we are going to get these failures, when there is multiple data are transmitted within a pipeline, and if there is no any sequences, and if there is many traffic congestion property occurs in this time, so at that time the two-way handshaking failure handshaking property will failure. To overcome this, we are having a three-way type of handshaking property. To overcome this, we are having a three-way TCP handshaking property. What it is going to do is, here we are having a client state with a server state. Both two constraints will be acting, but here once again we are having a particular, with the client and the server, we are having one host IP address. So here that it is going to, in the diagram you can check the client state. It's going to have the sync statement will be sent from the client to the server state. Middle we are having the host, right? So here it is going to sync the bit is equals to 1 by giving the sequence number example as a X. So it will be transmitted for the particular local host. Once it is directly, it is not going to connect with the server. Meanwhile, it is going to transfer the data to the particular local host. That local host, it will be choosing that particular sequence number, and it will going to check the connection. Then it will be passing for the server state. Here we are having a three-way of handshaking property. Middle version, in the middle, the host, the local host will be acting, and it will be updating the things between the connection between the client and also the server. It will be make sure make sure of the connection of the client and also the server. Okay, so here it will be whatever the messages, whatever the if I take one of the example, like I'm accessing some websites. Okay, so first I need to get the request, I need to get the access from the particular local host. Then only we are going to connect with a particular private websites. Okay, there will be a registration process. In the same way, this three-way of handshaking property will be going on. As I said, one example previously in your classes, in the same home, me and my brother will be transferring the data, right? That is a two-way of handshaking property. But when we need to access some particular healthcare or some any websites, we need to register first. We need to take the permission from that particular private accessing company. We need to get the requesting portal accessing from that particular private company. Then only we are going to initiate, or we are going to access that website. That is the three-way type of handshaking property. Same thing has been explained in this slide. Okay, then so it has been explained by using your FSM, final state machine, as we have seen in the reliable transmission machine, reliable data transmission, the 5 versions. So same way we are having the FSM state machine for this TCP three-way handshaking property, where you can see there is some acknowledgements, programs have been written, right? We are using the socket for the connection, and we are going to get into that particular application. So we are going to create a sync acknowledgement giving the sequence number and creating a new socket for the particular application invoking, right? Then we are going to transfer that sequence number to the we are going